Okay, so in this video, we're going to look at classifying the polygon ABCD, but we have to do it with justification, and this is required. It can't just be because it looks like it or because I think it is. You need to actually have good justification, and you use your analytic geometry tools to do that. So we plot the points. A is 3, 5. B is 7 over 6 up. C is 6 over 2 up. And D is 2 over 1 up. And so we need to do this. And so to do it, we first need to decide what are the different things that could come up. And we have the idea of a rhombus versus a parallelogram. And a rhombus is when all the sides are the same. Or we might end up with an isosceles trapezoid where the sides are the same length. And so we do have to consider, is it possible the sides are the same length? But it's almost always better to start with slope. And so what we do is we go through and we calculate the slope of these three sides. And so we say, for example, the slope of AB is going to be 6 minus 5 over 7 minus 3. Make sure you show some work on this. And so the slope of AB is 1/4. The slope of BC is 6 minus 2 over 7 minus 6, and so it is 4. The slope of CD is 2 minus 1 over 6 minus 2, so it's 1/4 as well. And then the slope of AD is 2 minus 1 over 6 minus 2, which is 4. So because the slopes are the same, that shows that opposite sides are parallel, which means this is a parallelogram. So we've determined that it's a parallelogram. It's not a trapezoid. It's not a kite. So once we know it's a parallelogram, we then have to decide, is it a rectangle and is it a rhombus? Well, the nice thing is we know it's not a rectangle because these slopes are not negative reciprocals of each other. They are reciprocals, but they're not negative reciprocals, so the sides aren't perpendicular. So then all we have to do is determine if it's a rhombus. The nice things for this, you only need to consider two adjacent sides, and because opposite sides in a parallelogram do turn out to be congruent, and so you can just consider two of them. If there are two that are the same, that means all four would be the same. So we just calculate AB using the distance formula. It's going to be 3 minus 7 squared plus 5 minus 6 squared, which equals the square root of 17. And then we can do the adjacent side to that. So BC, for example, or we could have also done AD. It doesn't matter which one. And that's going to be 7 minus 6 squared plus 6 minus 2 squared, which also equals square root of 17. So that means adjacent sides are congruent. Since opposite sides in a parallel are congruent, all of them are congruent. So this turns out to be a rhombus. If it said classify in the most specific way, rhombus would be the right answer. If it said give us all possibilities, you would need to include parallelogram and quadrilateral. It depends on what the directions say, but rhombus would be the correct answer to the way this one is worded. All right, to look at another one, we start out the same way where we graph our points. So we have 3, 3, 6 over 4 up, 7 over 1 up, and then 2 over negative 4 down. And you have to determine does this have a specific name? And so we start by, again, calculating slopes. And so the slope of AB is equal to 4 minus 3 over 6 minus 3, which gives you 1/3. The slope of BC is 4 minus 1 over 6 minus 7, which gives you a -3. The slope of CD is 1 minus -4 over 7 minus 2, which turns out to be just 1. 1 minus 4 is 5, minus -4 is 5. And then the last one, AD, turns out to be 3 minus a -4 over 3 minus 2, which is 7. So when I look at these, first off, I know it's not a parallelogram because none of the slopes are the same. I also know it's not a trapezoid because we don't have one pair of opposite sides parallel with similar slopes. I do notice this, where those are negative reciprocal, so it does turn out that this is a right angle. But that really doesn't do anything for us because it's not a parallelogram. If it was a parallelogram, then that would tell us it's a rectangle, but it's not a parallelogram. So instead, I need to check for the last thing, which is this a kite? And for it to be a kite, then we need to have pairs of adjacent sides congruent. So I've got to go through and calculate all four distances. And so I can just go through and systematically do that. So AB is going to be 3 minus 6, subtract the x's, plus 3 minus 4 squared. That gives me square root of 10. And then I can look at BC, and that is 6 minus 7 squared plus 4 minus 1 squared, and that's going to be square root of 10. And then CD is going to be 7 minus 2 squared plus 1 minus a negative 4 squared, which is going to give you a square root of 50, which does simplify, but you don't need to simplify it because we just need to show that they're the same. So for AD, it would be 3 minus 2 squared plus 3 minus a negative 4 squared, which also turns out to be square root of 50. And so since these two pair of adjacent are the same and these two pair of adjacent are the same, then this turns out to be a kite because the lengths of the sides are the same. Most of these problems, you're going to need to at least do all four slopes and two of the sides to get to the answer. Sometimes you're going to need to calculate all four slopes and the length of all four sides to be able to not just classify it, but classify it with justification. This stuff, and this is about as little work as I'm willing to let you show, right? You need to at least show that you've substituted it in, and then you need to do the calculation. I don't want to see less than that on your paper.